Hello everyone, my name is Tiberius and I'm going to walk you through CASTOR's use case 3 presentation, vehicle to everything and 5G cellular V2X safety communications in urban intersections. Use case 3 is about improving traffic safety using simulated V2X and 5G communications. We recreate a real urban intersection in simulation, and we use it to study three things: everyday traffic monitoring, emergency situations like accidents, and the detection of vulnerable road users, such as pedestrians and cyclists, so we can warn approaching vehicles in time. Why simulate instead of going straight to the field? Three reasons. We can assess how connected services improve traffic efficiency. We can safely test risky scenarios that you simply can't stage on a live road. And we cut the cost and complexity of real-world trials. But the challenges are real. We have to detect vehicles, vulnerable road users, and incidents from roadside infrastructure. We have to deliver the standard V2X messages, CAM, DENM, and CPM, with low latency and high reliability. We need to prioritize safety-critical messages when the network is congested, and we have to connect local perception with traffic operators and emergency responders. This is the baseline, the as-is world. Data is simply routed over a generic path. Whatever route the network picks, that's what you get. When we talk about availability, reliability, latency, confidentiality, none of these are taken into account when the path between the source and the consumer is established. It works, but you have no guarantees and no visibility into the trust of that path. Here's what CASTOR changes. Instead of a blind generic path, the path is now selected and monitored against network and trust requirements. CASTOR sits underneath the application and continuously assesses the trust and quality of the route. If the path degrades, the system knows, and it can notify. Same safety services, but now running over a path we can reason about. We organize use case 3 around 3 actors, each in a as-is and a CASTOR version. First, the traffic operator. The geo service provider builds environmental models from CAM messages and sends them to the operator, first over a generic path, then over a trusted path with KPIs displayed. Second, the emergency responder, who receives authenticated accident notifications, specifically the DENM classification, severity assessment, and alerts to local and central responders, eventually exchange over a trusted path. Third, the vehicle driver and VRU story issues warnings about vulnerable road users and collision risk using CPM and CAM correlation and trajectory risk detection delivered over a low latency path. These diagrams show how the actual message exchange behind each of the three workflows. In the traffic operator flow, each simulated vehicle beacons a cooperative awareness message, typically every 500 milliseconds, carrying position, speed, and heading. Those CAM messages travel over the 5G interface to the geo service provider, which fuses them into an environment model and pushes it to the operator. In the emergency flow, a vehicle detects a crash and emits a decentralized environmental notification. That message is promoted to the highest priority class, so it jumps ahead of normal CAM traffic. The GSP classifies severity and notifies to the local emergency responder, and, if it's severe, such as a multi-vehicle crash, it escalates to the central responder for cross-domain coordination. In the VRU flow, an intersection detection node emits collective perception messages. The roadside unit runs Kalman fusion and a collision predictor. When time to collision drops below the threshold, the policy engine bumps the warning to a 5 millisecond guaranteed flow and pushes it to the vehicles, all within our 200 millisecond budget. The platform splits across 2 virtual machines connected through a real operator testbed. VM1 is the simulation engine, an Ubuntu instance running Omnet++, Simu 5G, iNet, and Sumo coupled through Vanes and TraceCI. It reproduces the Podoroș intersection in Iași. VM2 is the operator interface on a different Ubuntu instance, a containerized Django channels and Daphne backend with the PostgreSQL event store and Edge local Valkey frontend by a SvelteKit UI. The two VMs sit on opposite ends of the Orange testbed. The simulation VM reaches the dashboard through an XRD virtual router topology with both ends joined over VPN tunnels. So every CAM crosses a genuine routed cross-domain network, which is exactly what lets us measure real latency and delivery, and later, real trust and path degradation. There's also a route probe exposed on that path for debugging and internal use, not for the operator view. On the first virtual machine, Simu 5G gives us the full 5G new radio stack. The roadside unit does the heavy lifting, message fusion, 5QI scheduling, and policy enforcement. The geo service provider node correlates incidents and the topology models real link delays. On VM2, the Django and channels backend ingests over REST and pushes over WebSocket. The SvelteKit frontend renders the live map, trust tiers, and KPI panels. That's the single screen where the traffic operator sees vehicle and quality of service, and the emergency responder receives validated alerts. Here's the dashboard in action. It visualizes traffic from the simulation on the Podoroș map. Every packet can be traced from the simulation VM through the XRD path, showing source, destination, route, and accepted records. Our roadmap runs across the projected timeline, so M1 to M18 to define the scenario, actors, messages, and architectures. M18 to M24 stand up the baseline environment and collect measurements without full CASTOR control. M24 to M30 integrate the CASTOR components. M30 to M33 run the controlled experiments across all three workflows. And M33 to M36, the final demonstration comparing baseline against CASTOR-enabled operation. We're measuring against 6 KPIs, traffic operator latency, end-to-end in the 10 to 200 second range, reliability, a delivery ratio of at least 99%, emergency alert latency, under 1 second to the local responder, under 5 minutes to the central one. VRU warning latency under 200 milliseconds, sufficient throughput for all 3 message flows. And finally, service degradation and trust level notification. CASTOR alerting on SSLA or path trust degradation. Each KPI has a first release, baseline, and a second release that adds the CASTOR trust aware layer. So here are a few key takeaways. Firstly, CASTOR can stay transparent to overlay applications. The operator workflow runs without major application changes, but transparency is not the same as active trust awareness. To really exploit CASTOR, applications have to query trust and path status and react to degradation. The baseline traffic operator flow is already operational and visualized in the dashboard. Route tracing is great for integration and debugging, but production views should abstract away sensitive internal topology. And cross-domain connectivity, such as VPN, reachability, routing, addressing, all of these things have to be handled early, given they are a real integration risk. So that's use case 3, a working trust-aware V2X safety platform moving from baseline toward full CASTOR integration. We'll now transition to a short video demo of the CASTOR dashboard, where you'll see the live CAM traffic on the Podoroș map. Hello. Today I am showing CASTOR's use case 3 from Iași, specifically the dashboard for a traffic operator. The point of the simulation is to show live data flow. The simulation starts, vehicles and infrastructure exchange messages in real time, and then we can see those messages into the dashboard VM. On the left, we have the XRD event path panel. Before the run starts, there is no active run and no packet evidence yet. On the right, we have the 5G simulation controls, the XRD route summary, and the map. I'm going to start the simulation now. When I click this button, the browser sends a start request to the dashboard backend on the dashboard virtual machine. The dashboard backend then calls the simulation helper on the second virtual machine. That helper is running on the simulation VM on the XRD network path. From that moment, the simulation VM begins producing live cooperative awareness messages, CAM for short, which are standardized periodic safety messages broadcasted by vehicles moving through the Iași and the Podoroș area. Those CAM batches travel from the simulation VM back to the CASTOR dashboard VM over the XRD path. The dashboard VM accepts the batches through its ingestion API, persists the latest CAM state, updates the current run, and starts polling the helper for ledger records and route evidence. The status strip now shows the simulation is running. It also shows live ingestion indicators such as CAM timing, ingest packet delivery ratio, and row count. Now, the XRD event path panel is filling with packet and route evidence. Each row is one observed transport event. It shows where the packet came from, where it was sent, which API route accepted it, and how many records were accepted when it was observed, and which route hops carried it toward the CASTOR dashboard. Now, the route summary gives the compact version of the same story: source, destination, and route hops. The left rail gives the event-by-event proof. The summary gives the current route context at a glance. The map is now being fed by the current simulation run. Each moving marker is a vehicle represented by live CAM data that has been ingested into the dashboard VM. We can also maximize the map when we want to focus on the live vehicle field. And we can also click on a vehicle. And with that, we can inspect the station ID, the time of the last message, the freshness of that message. We can also see position, speed, and heading of the vehicle. The panel also shows producer ID, request ID, simulation run keys, simulation time, source file, and line numbers, as well as sequence number. That matters because the operator can move from a live marker on the map to the exact evidence behind the marker. So if the vehicle disappears from the live feed, the panel does not silently pretend it's still current. It keeps the last selected summary visible and marks it as missing from the live feed. That is the fail loud behavior we want in an operational dashboard. So there we have it. This is the full demo loop. The left rail shows the data path. The route summary shows the trusted path at a glance. The map shows that those messages become live vehicle state. The vehicle detail panel shows that an operator can inspect the latest per vehicle CAM evidence. And now I am going to stop the simulation. The dashboard stops the simulator and waits for imported records to finalize. That prevents us from resetting while data is still draining into the VM. And now we can also reset the demo, which clears the current run, path rows, and vehicle feed, returning the dashboard to a clean, ready state. That completes our flow. We started simulation, observed secure route evidence, watched real-time ingestion, inspected individual vehicle CAM evidence, then stopped and reset cleanly. Thanks for watching.